Hey guys, this trend is about ionic radii. Okay. What the ionic radii is the radius of an atom that has either lost or gained an electron. Okay, it's going to be measured in picometers. Now remember, the radius is actually more or less built on the electron cloud. Okay, the protons and neutrons are found in the nucleus, which is a very small portion of the atom, but most of the atom is majority going to be the electrons. And we're going to talk about that more in a chapter coming up. Okay, first and foremost, we're going to look at the positive ionic ions, and those are going to stem from the metals. Okay, metals form positive ions. They essentially have partially filled s orbitals. They have lower ionization energy. There is a loss of one or more electrons in metal. So there are some metals that lose one electron, some that lose 2, 3, 4, 5, 6, 7, depending upon which one it is. And when you lose electrons, your electron cloud gets smaller. So it ultimately leads to a decrease in ionic radius when you lose electrons. Okay. Now, here we have an example. We have sodium. Okay. Sodium, when it loses one electron, the cloud actually gets smaller. All right. So I have a little drawing here. Let's check it out. So sodium, it starts out with 11 protons, 11 electrons. When it loses one electron, the number of electrons count goes down to 10. Therefore, it has one extra positive charge. And we note that with a positive sign right there. Okay? So cations lose electrons, therefore it shrinks in size. It's an important correlation. Okay? Now you can see, here's a list of all the metals. You have on the right side the metal element, and on the left side the ion. The red is smaller than the metal. Okay, that's because it lost electrons, therefore the diameter gets smaller. Now let's look at nonmetals. Nonmetals are a little different. Nonmetals form a negative ion. They have partially filled p orbitals. They have higher ionization energies, meaning ability to attract electrons. They can gain one or more electrons. So some nonmetals gain 1, some gain 2, some gain 3 electrons, which leads into an increase in the ionic radius. So it's going to get bigger if it's taking in more electrons. The electron cloud grows. So here we go. Here's chlorine. Chlorine has 17 electrons, and 1 electron gets brought in. Okay, so the diameter gets bigger. So let's take a look at the drawing I chose here for oxygen. Oxygen starts out with 8 protons, 8 electrons. Now, when 2 electrons come in, the number of electrons grows from 8 to 10. Therefore, we show with the sign that there's 2 extra electrons. Okay? So this is the sign that oxygen has gained those 2 electrons. Okay? So here on the right side, we have now the nonmetals. We have the gray, which is the element, and the blue, which is the ion. So you can see the blue is bigger than the gray. Okay, that's because the blue is where it has gained the electrons. Okay, group 7A gains 1 electron, group 6A gains 2 electrons. So the blue is going to be bigger. So the anion is going to have a larger diameter. It's going to grow in size. Now, there's a general trend that goes along with this. So let's take a look here. Okay. So cations and anions are kept separate with this whole thing. They're a little different because cations shrink in size, anions grow in size, so they're going to be kept separate by this black line. Now, let's look at the general trend going across the periodic table. As you go left to right across the periodic table, the atom generally decreases in size, left to right. However, if we look at the ionic radius, okay, it still decreases going left to right. However, there's a trend here that's a little different for the nonmetals than the metals. Okay, so lithium loses 1 electron. It shrinks down to 60 picometers from originally 156. Beryllium shrinks to 44. 44 is less than 60, so left to right, it does shrink. Now looking at the nonmetals, generally speaking, okay, nitrogen is 70. It grows to 146. Oxygen goes from 66 picometers and it grows to 140. 140 is still less than 146, so to the right it gets smaller. And fluorine is 62 picometers, it grows to 133. So as left to right across the periodic table, across the nonmetals, it decreases left to right. Okay, so let's look at another trend. Okay, so here we go. So like I said, the atomic radius decreases left to right. However, the ionic radius, there's going to be 2 arrows, one for the anions and one for the cations. Now remember, anions gain electrons, nonmetals lose. They have to have 2 arrows for this. So here are the trends for ionic radius they need to be familiar with. As you move left to right across the periodic table, the electron cloud shrinks due to the increasing nuclear charge acting on the electrons in the same main energy level. Therefore, cationic and anionic radii decrease across the period. As you move down the periodic table within a group, the outermost electrons in both cations and anions are in higher energy levels as one reads down a group. Therefore, the ionic radius decreases down a group. Okay? Now let's look at some questions that go along with this. For each pair, which element has a larger ionic radius? Okay? Pause the video, find them on the table, and determine which one is larger than the other. Okay, so let's check your answers here. The red is the correct answer. All right. So hopefully you were able to identify that. And that's where we're stopping.